Hi, previously we talked about some examples doing the curtailments of reinforcement bar using the simplified rules for simply supported slab. Today we're going to try another example doing the curtailments of reinforcement bar. This time we'll deal with the continuous slab. Now before we talk about this example, something that you ought to know, there are two simplified rules for continuous slab. The first one you can obtain from British Standard at 110, figure 3.25. The simplified rules for the curtailments of reinforcement bar in the continuous slab is illustrated here. This represents the bottom reinforcement bar and this represents the top reinforcement bar. The percentage here indicates the amount of reinforcement bar to be provided at different locations of the member with reference to its supports. Now, if you find this difficult to understand, I have it illustrated here. It should look something like this. Now, the second method here, you may refer to the references written by Mosley. This is the cover page of the reference. Reinforced Concrete Design to Eurocode 2, written by Mosley, 7th edition. You may refer to figure 8.2. The simplified rules for the continuous slab is illustrated here. The two approaches, although looks similar, there are some areas of differences. I have it sketched in order to show the differences, which normally happens to the end support. What you see here, according to the British Standard, you can do the curtailment near to the support with the amount of reinforcement bar of at least 40%. This also applies to the interior support. The locations where you're going to do the curtailments are the same, except that the amount of reinforcement bar varied slightly. The second differences, it will be the top reinforcement bar at the end support. British Standard require a greater amount of the reinforcement bar as compared to the Mosley references. Bear in mind that this 50% and 25% is referring to the mid-span reinforcement, not the amount of reinforcement at the interior support. Let's say now you have specific amount of the reinforcement at the midspan. As a rule of thumb, you reduce the area by half for the British Standard. And for Mosley, you reduce to 1/4. The next differences, it will be where you can do the curtailment. This one specified by 0.15 L and this one specified by 0.2 times the L. Despite that, British Standard also specified that this length here must be at least greater than 45 times the bar diameter. In fact, similar principle may be applied where you're going to set this in accordance to the minimum anchorage length. This 45 times the bar diameter typically represent the tension anchorage length in the context of the British Standard. Since we talk about the anchorage length defined by the British Standard and the Eurocode differ slightly. In British Standard, you can get the required anchorage length from table 3.27. Whereas in Eurocode, you will need to do the calculations accordingly. One special thing about the Eurocode is that the anchorage length is significantly governed by the locations where the reinforcement bar is placed, whether it is under a good bond conditions or poor bond conditions, which the British Standard do not differentiate that. Now, having the differences between the simplified rules of the British Standard and the Mosley references, let us look into the example. In this example, we will use the British Standard, guiding us how do we do the curtailments of the reinforcement bar in the continuous slab. We will try the Mosley method in the other example. Now, given the dimensions of the slab, the span is 4.5 meter, the thickness is 125 mm, and we are talking about the main bars. Since the member is lightly loaded, we intend to provide as minimum amount of reinforcement bar as possible. Therefore, the first proposal here, it will be #10 450 for both the bottom reinforcement bar and the top reinforcement bar. But you know that this will be subjected to change. Why is it so? Since we are dealing with the main bar, you know that this 450 will definitely fail in terms of the maximum bar spacing. Now, having the conditions set here, let us look into the design process for the curtailments of the continuous slab. We are dealing with the main reinforcement bar. The span is 450, the thickness is 125. We put #10 450, #10 450. You know that the maximum spacing will fail. How do you know that? We will need to look into the requirements for the maximum spacing. There are two methods for you to determine the maximum spacing. The first one, it will be more straightforward, which is governed by the multiples of the thickness and a maximum of 400 or 450, depending whether you are dealing with the main bar or the secondary bar. For the main bar, you will use this, and for the secondary bar, you will use this. This simplified method is conditional when your thickness is less than 200 mm. Exceeding 200 mm, you will need to use this formula to determine the stress in the steel bar, and then refers to the Euro code, table 7.3n, based on the steel stress calculated, referring to the column of the crack width of 0.3 mm, you obtain the maximum bar spacing through interpolations. Coming back to this example, your thickness now is 125 mm, which is less than 200 mm. That means you know that you're going to use either of these two formulas. You are dealing with the main reinforcement bar. Therefore, this formula will apply. Choose the smaller value of these two. 3 times 125 mm give you 375. Compare with 400, 375 is smaller. Therefore, you know that your maximum spacing for the reinforcement bar, it will be 375. The initial proposal here is 450. It fails. What you can do now is to reduce the spacing from 450 to 375. Now you have no issue with the maximum bar spacing. Second thing that you need to check, it will be your AS minimum. For you to determine the AS minimum, you may use this formula. Let's say now your concrete grade is 30 and your nominal cover is also 30. For a slab, we are designing it on the basis of 1 meter unit width. Therefore, the B here refers to the 1 meter width. As for the effective depth, you need to first know whether you are designing the main bar or the secondary bar. In this case, you are designing the main reinforcement bar. To get the effective depth, use the thickness of the slab minus the nominal cover, which is 30, and then minus half of the diameter of the steel bar. This will be the effective depth to the bottom reinforcement. You will do the same for the effective depth of the top reinforcement. Use the thickness of the slab minus the nominal cover minus half of the bar size. Having the effective depth of 10, you need FCTM. You may refer to table 3.1 from the Eurocode 2, or you can get FCTM from the formula here. FCK is 30, that means you can use this formula. Substitute into the formula, you get FCTM equals to 2.9. Your AS mean calculated, it will be 136. Compare with the amount of reinforcement bar provided, it is sufficient. That means you have no issue with the maximum spacing as well as the AS minimum for both the bottom reinforcement bar and the top reinforcement bar. Since the British standard has a anchorage length as defined by 45 times the bar diameter, we can calculate the anchorage length here. 45 times the bar diameter. And this one is applicable for the top bars here. Therefore, we only need to generate one. In industrial practice, for a typical slab, normally we will use the same size throughout the slab, depending on the situations. Under normal circumstances, the amount of reinforcement bar, it will also be more or less the same. Now that we have done checking all the necessary items, we will look into the curtailments of the reinforcement. We deal with the bottom reinforcement bar first, as it is simpler. The reinforcement bar at the midspan is H10375, which is standard allows you to reduce to 40% near to the support. The more realistic way for you to reduce it, it will be keeping the same size of the reinforcement while doubling up the spacing. That means you do the curtailments of the reinforcement bar alternately. Something like this. Your spacing here is 375. If you do curtailments alternately, that means near to the support here, the spacing will be double. But you will need to check whether the maximum bar spacing and the minimum bar area allow it. If you double the spacing here, it will become 750 mm. Your maximum bar spacing is only 375. And if you double the spacing here, the provided bar area here it will be reduced by half, 104.5. But your minimum bar area, it will be 136. Both the maximum spacing and the AS minimum do not allow for that. Therefore, no curtailments will be required for the bottom reinforcement bar at the support. That means you are providing H10375 continuous up to the support without any curtailment. Next, we deal with the reinforcement bar at the support here, which is standard states that 50% of the amount of reinforcement bar here. 50% means 104.5 mm squared, and this amount is actually less than the AS minimum. There is no point for you to reduce the amount. You might be able to avoid the maximum spacing by reducing the bar size. But you know that in the industrial practices for the slab design, the smallest bar size that you can use for the slab, it will be 10 mm. Eventually, if you really need to reduce this as provided, the only options that you can get, it will be double the spacing. Doubling the spacing here, you will have issue with the maximum bar spacing. Overshoot this 375. Therefore, at the end of the day, you will need to provide the same amount of reinforcement bar at the end support as the top reinforcement, which is H10 350. Now you need to determine the locations where you can end this bar. Two conditions here. It is either 0.15 times the effective length, or it must be greater than 45 times the bar diameter. 0.15 times the effective length of 4500, you get 675. 675 mm is greater than 45 times the bar diameter, which is 450. You will choose the bigger value of the two. Therefore, you know that the reinforcement bar will end here at 675, as indicated here. Next, we will look into the top reinforcement bar at the interior support. The provided amount of reinforcement bar is #10375. Merely pass the requirement for the maximum spacing and the as minimum. Although the simplified rules here allows you to reduce the amount to the half, starting from 0.15 times the effective length. However, based on our experience here, you know that this will not pass. At the end of the day, there will be no curtailment. That means you will keep the same amount of reinforcement bar extended up to here. The final location here, it will be equal to 0.3 times the effective length, which in this case is 1350, compared with 45 times the bar diameter, which is 450. That means you can end the reinforcement bar here at a distance of 1350 from the face of the support. Finally, the provided amount of reinforcement bar will look something like this. The initial plan was to have #10 450, but you know that there will be issue with the as minimum and the maximum bar spacing. After revisions, we use #10 375 without any curtailment. Since we don't do the curtailments for the bottom reinforcement, there is no need for us to identify the locations the curtailment should be done. Same goes to the top reinforcement. But you will still need to identify where the reinforcement bar should stop. Your final design outcome should look something like this. After considering different aspects of the design,